Hello, and welcome to Calculus Lesson 135. Today we have a quite quick lesson, so you'll see that I'm on the abbreviated board over here. So today we are going to work on absolute convergence. So this is another one of your convergence tests, but in this case, it has to do with the absolute value. So let's check that out. If the sum of the absolute value of a series converges, then that series also converges. Okay? So I'm saying that if the absolute value, so you take each term, take the absolute value of it, if that whole series, if you add all of those up, that converges, that's most likely going to be a bigger number than if you take these, right? Because if you have a mix of positives and negatives, you probably have some big numbers, some negative numbers, they kind of cancel each other out. It's easier to have this converge than that. So if the absolute value converges, then this is said to converge absolutely. Don't you want more absolutes in life? Like, when is coronavirus going to be over? When can we stop wearing masks? When we go from the, where we, go to the maitre d' to be seated and then to our seats at restaurants, but we're still without masks at the restaurant and outside. Anyways, we want all of these absolutes in life. Jesus gives us those. Jesus gives the absolute truth. And the rest of it, we're just grasping at straws. And so, I think this is a really important lesson for us because sometimes we just need to go back to absolute truth, which is the Bible, which is the Word of God. Okay, so how is this going to work practically for you guys in these problems? They're going to ask you, hey, here's a series. Determine if it converges or diverges. So we have -1 to the n plus 1, so that means it's going to be positive, negative, positive, negative, positive, negative, but it's all over n cubed. So the idea with this is that if I take the absolute value of this, the -1 goes away, and I'm left with 1 over n cubed. We remember that this is a p series with p greater than 1, so it converges. So I'm going to say that the sum of -1 to the n plus 1 over n cubed converges absolutely. And that's it. Let's try another one. This time we're going to use cosine over n squared. Now, cosine of n is a number between -1 and 1 inclusively. So, if I take the absolute value of it, then that gets rid of the negatives, and I know that this is going to be 1 or less. So I know that this, if I take the absolute value, is always less than or equal to this. Why? Because the highest number, the absolute value of cosine is going to be 1. So it's always going to be less than or equal to 1 over n squared, but this can always be smaller than 1. So I'm going to do a basic comparison here. This is less than or equal to this. This is a convergent p series. So this cosine n over n squared converges absolutely. So you kind of have to pick up all of the things that you've learned already in this class in order to be able to do this. But you know all of the tests. It's a matter of applying them. Okay, last one. So here we go. We have -1 to the n plus 1 times 1 over n. Now, we look at this and we go, okay, well, let's take the absolute value. So that gets us 1 over n. We know that this diverges Therefore, we can say nothing. Be careful. What did our absolute convergence postulate tell us? It said if the absolute value converges, then we can draw a conclusion. Can we draw a conclusion if it diverges? No. So we can draw no conclusion. So you're going to have to use some other test to figure that guy out. We're going to go over this in lesson 138, so we'll skip that for now. So that, my friends, is problem set 135.